Good afternoon, ladies and gentlemen. Good morning to those of you in the West. Thanks for joining us today. We have unprecedented numbers. We're close to maximum, which has actually never happened before, and we really do appreciate you all taking your time to join us today. The topics today are basically LED lay-ins. Some of you may recall some of the original webinars we did on flat panel LED technology. And at that time, let me tell you, the watts were about 90 watts for a 2x4. The lumens were slightly less than what you were getting delivered from a 3-lamp T8 2x4 fluorescent fixture. And really what we were touting was the energy efficiency that can be gained through controls. And that was really the only way to get a return on investment at that time. What a difference almost 2 years makes, where we will demonstrate that LED Troffers outperform fluorescent in a manner in which you get a return on investment in 5 years or less and have many more controls. So let's get started. What we've done here to demonstrate these important points is to build a faux room, a fake room. In this case, our room is 60 feet by 30 feet with 10-foot ceilings, which is relatively typical. This space could be, you can imagine it as a large classroom. You can imagine it as a office space, maybe with high wall or low wall cubicles. Many applications for a 60 by 30 foot. Now that yields an RCR of 1.88. For those of you not familiar with room cavity ratio, basically a perfect cube of a room would be an RCR of 10, and the flatter the room, the lower the RCR. In this case, 1.88, which again is relatively typical for a large workspace. What we've done here for reflectivity is we've calculated what is considered typical. 80% reflectivity on the ceiling, 50 on the walls, 20 on the floors. These numbers can be couched to specific applications, but this is what's considered a generally high reflectance application. And the work plane, for no particular reason, at about 2.5 feet, which is about where a desk surface or a work surface would be. Now, we'll talk about the luminaires, the fixtures that we're putting into this 60 by 30 room. On the top here, what we have is the latest MaxLite 2x4 EcoT model. This is a fluorescent-looking LED fixture, made actually in a fluorescent fixture. The number of lamps here is 1, as the lamp is integral to the fixture. The total lumen count at about 4,500 lumens, a light loss factor of about 4 or 5%, and a coefficient that yields a coefficient of about 4.94. Now, on the other side, we have the fluorescent, same mounting height of 10 feet. This particular fixture is a high-end fixture made by a very reputable fixture manufacturer. If you really want to know, you could look up that catalog number there. This is a 3-lamp T8. 3 lamps included, about 2,800 lumens total per lamp. This has a LLF, a luminaire light loss factor of 0.64, and yields a coefficient of about 0.71. So there's our apples to apples on the fixtures. Now, we have the room, we have the fixtures in the room. Now let's take a look at the output of these fixtures, what these different technologies will yield. And as you can see on the right side, the placement of the fixtures are identical because they are identical in size and remarkably similar in photometrics that we'll demonstrate shortly. The fixture spacing is identical in this particular space. Now on the top we have the LED that has a 34-foot candle. 15 fixtures in total, laid out on a 5x3 grid with a 12 and a 10-foot spacing, and columns start off the wall, off the corners at 4 foot by 4 foot. This gives us a power density of 0.47 watts per square foot. Now this is phenomenal. And those of you paying attention to power density numbers, let me assume that many of you don't know the power density numbers. These are the numbers that are the bottom line for the EPAC laws. The lighting portions of these EPAC laws are requiring lower and lower watts per square foot to light up your space. And we have seen now incentives as low as 0.5, and we are demonstrating that we are there. Very difficult, by the way, to do with fluorescents. Now, let's take a look here. And this, again, is a very efficient fixture using high lumen lamps. We have almost the same 32 foot candles. The number of luminaires and the spacing is identical. Again, the workspaces are being treated as a single workspace with two different technology assumptions. And here we have a power density of 0.7. Now, I mentioned this is a very efficient fixture, and it is. And this is about as low as you can get with typical fluorescents without getting into the more expensive dimming fluorescents or the more expensive low wattage lamps and the like. Now we're going to take a close-up view of the LED, and then we'll take a close-up view of the fluorescent so that we can see exactly what we're dealing with here. So in this case, we are looking at a 3-lamp fluorescent fixture. It's yielding us about 32.4 foot candles as an average, with a max of 44 and a minimum of about 12. Now notice in the top right hand corner that 11.7 foot candles. That if I had made this room 55 feet as opposed to 60, you would see those low numbers drop right off, and that probably would have been more appropriate. But as it is, this is the best layout that we can do with this particular fixture. And it does yield a pretty high min-max ratio, which again could have been better handled for the purposes of this webinar. But I wanted to show a very real-life scenario. And our average min to max is about 2.8 to 1. If we had dropped out that far right section of the building, that would have come up closer to maybe 1.8, 1.9 to 1. Now I want to just bring your attention to various other spots on the floor plan of this particular workspace. Top left-hand corner, we have almost 24 foot candles directly below the fixture. We have 40, 39.5, 42. In the middle column against the wall on the top, we have about 24, 25 foot candles. Below the fixture, 41. Then again, 41 between the fixtures, 44. This is our hot spot in the center of the room, mainly due to reflectivity that we talked about earlier. So you get a rough idea of that we're running in the mid-20s along the top, about 40 or 41 directly below the fixtures, and a little bit less between the fixtures. Now let's jump over to the LED version of this very same room, same dimensions. Now our average has come up slightly from 32 to close to 35. Our max 49, min 12, and again the min is in that same dark corner with a 12.6. If we had cut this room a little shorter, these min-max ratios would have looked a lot better. Now let's look through the floor. Top left corner, we're looking at about 24 foot candles. Directly below the fixtures at about 44. Our hot spot with the fluorescent was at 44 in very few spots. As you can see here, our hot spot is 49. So with the typical lumen depreciation of LED, you're looking at 20 to 22,000 hours before these even come down to where the fluorescents begin. And depending on the manufacturer of the fluorescent lamps, the lumen depreciation there could be a slower slope, but overall lifetime is much shorter. So as you can see on a 1-to-1, we have outperformed the fluorescents in absolute delivered foot candles on the work surface. So I'm going to remind you of where MaxLite and others started about 2 years ago, where we're running 90 plus watts to achieve similar light levels to fluorescents, which are running at about, let's say the low to mid 80s, depending on the lamp ballast combination, but typically 84, 85 watts. We could get that down, no doubt about it, but our costs go up, and it's not typical. This is a typical. The newest LED lay-in troffer from MaxLite, our 2x4 Eco, is 56 watts. Now, in this particular scenario that we have built with the 15 fixtures, this is a 24-hour-a-day application. Let's say it's community service center. It operates 7 days a week. They're paying 15 cents a kilowatt. We used to use 10 cents. Actually, way back we used 8 and 9 cents for demonstration purposes because it was an average maybe across the country. Then it was 10, then it's 12. Now we're using 15. And, I talk to people every day who are paying over 20 cents a kilowatt hour. So that varies widely, but we use 15 just for apples to apples demonstration purposes. So our cost per day for operating a typical fluorescent 3-lamp T8 fixture is about 30 cents a day per fixture, about $2 a week, or about $9 per month. Now let's replace that fixture with the MaxLite EcoT at 56 watts. Same hours per day, same kilowatt hours, obviously, same size room. Now we're looking at about 20 cents a day per fixture, or $1.40 per week, or about $6 per month. We're looking at a 30% savings in energy right out of the box. Now if we look at cost of ownership of these fixtures, and I have not included maintenance, you can plug in your own numbers for maintenance. There is no good average across the nation. New York, Chicago, you can be paying $150 to somebody who changes light bulbs under certain conditions, and in the Carolinas and in the Midwest you can be paying minimum wage for changing those same bulbs. So that's a rather large variable that I just decided not to include so that we have some real numbers. So the cost of power, the electricity on a 3-lamp T8, is about $550 per fixture in 5 years. The cost for replacement bulbs is about $90 in that same period, a total of about $640 for ownership. With the EcoT that we're using in this example, the EcoT 2x4, we're looking at about $370 for the cost of power. There's no bulb replacement, so we're looking at about the same $370 savings. So just in a power to power, without using any controls, without utilizing some of the built-in and optional features of an EcoT, we have tremendous energy savings alone. So boy, have we come a long way in such a short period of time, where we started off at 90 watts, slightly higher power, and could not show you an energy return on investment without use of controls. Today we can show you a substantial energy savings without use of controls. So here, with a 15-piece retrofit, without using any controls, assuming that there's no utility contribution whatsoever, I use an example of $200 for the fixture. It's somewhat of a realistic number, but I acknowledge that there are all types of folks who have joined us today, from the end users, purchasing agents, facility managers, and then of course we've got distributors, ESCOs, and contractors, as well as you reps and other interested parties. So the $200 is a per fixture cost roughly to the end user when there are no utility incentives. Now just below we have the identical scenario, but in this case there is a $50 contribution from the local utility, which brings our ROI from about 5 years at 65 months to less than 50 months. And again, this is just on energy. Now, without taking any due credit or acknowledgement from the good folks at such companies as Lutron as an example, let's face it, fluorescent controls are difficult. They are expensive, and they are not typical. If it was easy, we would do it everywhere. Why not? If you can put fluorescence with compatible controls without any downsides, such as quicker lumen depreciation due to a lot of on and offs, maybe with a motion control, or short of life because a not perfect or not quality made dimming control was used, or dimming ballast. With LEDs, these are not issues. It's practically free to control LEDs. Remember, solid state lighting, SSL or LED lighting, has more in common with your PC than it does with a incandescent or fluorescent bulb. So what we knew in the past is kind of irrelevant for going forward, and controls absolutely should be a part of your considerations for all jobs going forward. Let's focus on the most popular control, which is dimming. Dimming with LEDs is actually additional energy savings. With a quality-made dimming LED product, your dimming ratio, your energy ratio, is approximately 1-for-1. In other words, if you had a 1,000 lumen lamp at 10 watts and you dimmed it to 50%, you're now at 500 lumens at 5 watts. In many cases with fluorescent dimming, that is not the case. Actually, as the dimming goes down, the efficacy goes down as well. That happens often. Dimming, in the case of LEDs, in most cases, actually prolongs the life of the LED and the electronics because it runs cooler. and it also decreases the lumen depreciation. I think that's a double negative. So it does not push the depreciation down due to the fact that the phosphors used in LEDs are keeping cool as well. So not just the electronic components, including the LED, but the phosphors used in the LED all have extended lives with dimming controls in many cases. Now, why do we use dimming? We use dimming for ambiance and to suit our application, to suit the functions going on in the space. Restaurants, theaters, presentation spaces, conference rooms, these are all good applications for dimming controls. And frankly, in the past, in restaurants and theaters, in presentation spaces, there usually was not the budget for putting in fluorescent because of the dimming is so expensive and the performance is not as good as incandescent. So these are generally applications that were still left with non-energy efficient lighting. So, there are still restaurants, theaters, and presentation spaces are still big users of incandescent lamps, particularly PAR and R-type lamps, to get this effect, to get the ambiance. And now we can replace those fixtures with LED, and we can have energy efficiency and dimming. Dimming more or less just creates a lot of flexibility for a space. For instance, in schools, you have multi-purpose rooms where it's a gymnasium today and it's a theater tomorrow. Dimming certainly contributes to that. And in office space, you want to have the flexibility to move the cubicles around, completely change spaces around. MaxLite has grown tremendously in the last 20 years, and we have stepped up our size and built on as we moved. And we love the fact that we have the flexibility to move workspaces around as the company needs require it. So I can go on and on about dimming for all the old reasons why we always had it, and all the new reasons now because we can do it. We can do it practically for free and can do it without sacrificing energy efficiency. Additional controls include daylight harvesting. Generally, hospitals and facilities of education are great applications for daylight harvesting. For those of you who might not be familiar, you need to catch up. Daylight harvesting it's been around and used with fluorescent dimming systems for many, many years. Basically, as the natural sunlight comes into the space, the controls will automatically dim the LED products now so that the work surface always has the same amount of foot candles. There's always the same amount of ambient light in the room, but it switches as the sun moves from a combination of mainly natural sunlight to obviously after sundown to completely man-made light. And when you automate this is tremendous energy savings in applications that are built with natural sunlight in the workspace. Additional energy savings, or the best time for energy savings with daylight harvesting, tend to be in the hours when we are most busy. So when it's an option, absolutely it should be considered. Some people get a little sticker shock with daylight harvesting systems, but remember, you generally only need a few controls for the whole application. It's not like you have to put a control on every single fixture. It doesn't work that way at all. Additionally, I've been to some applications that have shade control. When that natural light is there and able to come inside, Luminaires takes over by keeping the shades or the blinds closed. Shade controls can be built into this system as well. Another whole method of controlling products are occupancy sensors. Now, with bi-level dimming and occupancy sensors, and remember, products like MaxLite's LED, Troffers, and the EcoT all have the ability to work with occupancy sensors, motion sensors, daylight harvesting systems. In an extreme example here, you can have lights dimming down to say 10% as people pass under the fixtures and turning on 100% several fixtures out in front of you, and completely observing when the space is occupied and when it's free. And remember, you don't have to have them just on off, but you can have them say in periods of time when there is no occupancy, go to 30 or 40%. And when occupancy is detected, go up to 100%, or maybe even only 80%, which is something else you can do. You can have your maximum light level at a dimmed level as well. Now, not all applications are compatible with occupancy sensors. They really are all compatible, but in some cases it just does not make sense. For instance, if you have an office pool with a number of employees in cubicles, There's constant space there, and that application is probably better done with timers than with motion controls. A private office, however, where there is not constant movement, it's either occupied or it's not, could be a great application for occupancy controls. Classrooms, again, because there's constant movement, there's generally long period of time where there is constant occupation and then long period of time where there is none. A timer is probably a better control for that application. Conference rooms, again, some places the conference room is on all day when literally no one has entered that conference room. Certainly a motion sensor is a great area for saving energy. Storage rooms and restrooms are also great applications. Now we are going to jump over to a training module. This is the commercial part of our webinar today. And we're going to plug two things today. We're going to plug the brand new service called university.maxlite.com, which is MaxLite Lighting and Technology University. Come back next week and you will find the coming in July portion up and running, which we're very, very excited about. Right now we're going to focus on LED indoor fixtures. And because I referred to it so often and because I use the IES files in our webinar session today, I will run through the basics of the EcoT in a short period of time. So the EcoT does come in both 2x2 and 2x4 sizes. These are actually high-end fluorescent fixtures. They utilize the same finisher on these housings, the same door, and the same lens, all from fluorescent fixture. What we don't have here are fluorescent sockets. As a matter of fact, there are no sockets in this fixture. We have LED strips and a driver. Features and benefits which we have discussed throughout the presentation today, but more specifically in the Kelvin temperatures you can get in the 2x4 as high as 4900 Kelvin and a 2x2 approaching 3800 lumens at 5000 Kelvin. 4900 at 5000 Kelvin on the 2x4 and almost 3800 at 5000 Kelvin on the 2x2. Now, these are delivered lumens. These are not the total lumens, but the delivered lumens. We will be doing a webinar in the near future to elaborate more on that, as LEDs are not just changing the way that we describe life of products, but the way that we describe lumen output as well. And in this case, we are looking at about a 30% depreciation, L70, at about 50,000 hours. This assumes no dimming. These numbers run out for the better as you dim, as you add controls. We have a 0 to 10 volt dimming as well as simple dimming system and a high CRI of 85. These work with typical 2x2 and 2x4 grid type ceilings. Additionally to the dimming controls and the 0 to 10 control, we have a master satellite configuration which allows for an example where we're going to put a 0 to 10 dimming switch on the wall. We would run the dimming switch only to the master fixture. The master fixture will then in turn control the satellite fixtures with the supplied RJ cord. And further, not standard, but optionally, we could add DMX controls so that you can have full building automation. Additional specifications. This is somewhat of a cure for insomnia, and I won't read this out to you, but the basics beyond what we talked about already is efficacies as high as 90 lumens per watt. This is cutting edge stuff, folks. Ambient temperatures as low as minus 20, as high as 130 Fahrenheit. So that's a pretty broad range. We have dimming, as we spoke about. The physical size and shapes, again, are identical to fluorescent. Like fluorescent, these have universal drivers, so 120 through 277 is not an issue. And we have IES files, data sheets, LM79 data, and much, much more for your download. You can find them either here directly in this module, or you can visit maxlite.com and go to the EcoT Product section, and you'll find all of these same files available for download there. I wanted to show some pictures just to show the evolution of this product. What you're looking at here on the extreme right, labeled D, is MaxLite's first LED product. This was a 90-watt 2x4 edge-lit product. Next to it, we have a fluorescent 3-lamp 2x4 fixture, very high-end, high quality with brand new lamps. Next to that, we have labeled B, the 2x4 EcoT model. This is the actual fluorescent replacement that has remarkably similar photometrics, and also the 2x2 EcoT model. A couple more photographs for you. This is a colleague of mine, Bill, who was visiting our West Coast showroom and laboratories, and he was challenged with choosing which is the LED, which is the fluorescent, and it was not as obvious as you would think. Very difficult to tell through the lens. Some additional pictures for you. Now, we also have a return on investment calculator available for you to download anytime. This return on investment calculator has drop-down menus, so you can either start with the fluorescent fixture, choose the type of fixture that you're using, and it will then in turn recommend the proper EcoT model, or vice versa. If you know you want a 2x2 or a 2x4, choose that model, and it will lay with it the fluorescent comparable and give you very quickly a return on investment. You can customize this to include your specific job parameters, kilowatt hours, hours per day. There is even room for putting in rebate money where that applies. It also outputs a nice graphical image of the bottom line on your return on investment spreadsheet. So for more details, do come back to university.maxlite.com and go through that module in more detail. You can also download it so it can be viewed at your leisure. And you can also look at all the other MaxLite product modules. Come back next week and you will find some really good new information that we have added to the university, including a Earn Your Degree section where there's actual questions and answers after a study period. You can log on, set up an account, feel free to use it for yourself, for your employees. This is not a commercial for MaxLite, but it's really a fundamental lighting 101. After they've gone through all the modules and questions and answers and have passed, they can move on to intermediate. And for you lighting professionals, we even have advanced, where you might pick up a thing or two if you go through that as well. So any feedback on it would be wonderful. We'd love to hear about it. Let us know what you think. Now, we will leave this session open for a few more minutes for any of you who may have any questions. And we will get back to you with answers directly within 24 hours or so. We'll also include the slides that were used today, as well as the EcoT PowerPoint presentation. Again, thank you so much for joining us today. We hope that we contributed to your business and your bottom line.